Good morning, everybody joining us today. Welcome to our webinar, our episode 4 of our Lightning Web Components series. We're going to talk about security, testing, debugging, and a lot of other good stuff. My name is Shashank Srivatswaya from the APAC Developer Relations team, and I'm joined today by our Senior Developer Evangelist, Satya Shekhar. Hi, Satya, how are you?
Hi, Shashank. I'm good.
Are you ready for today?
Yeah, all set.
All right, so before we go ahead, let me tell you that we might make some forward-looking statements about features that are not yet generally available. And since we are a publicly traded company, don't make any buying decisions based on what we're going to talk about today. And we are all up for social. Please feel free to tweet us out on @Salesforce Devs. And we are available on Facebook and LinkedIn as Salesforce Developers. And please also feel free to check out all our amazing content that we host on our YouTube channel, which is again Salesforce Developers. And for people who are wondering, please note that this webinar is being recorded. For anybody who has that question, we are recording the webinar. And the way to access the recording and the slides is after we are done with the webinar, we are going to update the page that you use for registration with the recording and the slides. So you can just get the recording and slides right after we upload it, and it's there for you, right? So with that out of the way, let me tell you about the Q&A that we're going to do towards the end. We're going to do live, we're going to look at all the questions that you guys can keep posting during the live webinar. And towards the end, we'll answer as many questions as possible. So please feel free to keep posting your questions as you get them. While the webinar is going on, in the questions tab in GoToWebinar. So you have a tab to actually specifically post questions. So any questions you have, any concerns, just feel free to post it out there, and we'll do a live Q&A towards the end. Other thing is, if you have any issues with audio or video, the best way to fix it is to just exit the webinar and join again, and that fixes the things most of the times. Like 99% of the times, the things are fixed. With that, let's hear from Satya about a recap of our previous episodes. Over to you, Satya.
Yeah, thank you, Shashank. It's a recap. It's very important. Why? Because we will be having few of the joinees today who are very much to the webinar 4. So I just want to give a quick recap on what we have done in our episode 1, 2, and 3. We started our webinar series talking about the basics of the Lightning Web Components and why it is introduced, how it is introduced. And then we learned about the sample gallery and how we can leverage the projects or applications that are in sample gallery to learn more about all the concepts of the platform, and specifically Lightning Web Components, wherein we have 2 special applications dedicated for the Lightning Web Components. One is Lightning Recipes, which we have been using widely now, and there is one more project which is e-bikes. So I suggest people who are watching this webinar, go back and look at those applications as well, and you can find very good examples there. And then we also talked about component library and playground, where we can build some front end for the Lightning Web Components, and we can quickly do some prototyping of the applications there. And component library is much powerful, where you can see more. Lightning component library is much powerful, where you can see the references for the various components there. And we also talked about base Lightning components, and then a little about developer tooling, from where we started developing the applications for the Lightning Web Components. We learned about Salesforce CLI, and we learned about VS Code, and we had a quick demo there. And episode 2 was specifically dedicated to the data, how we access the data from the Salesforce org, and also how we store the data into the Salesforce org, right? So there are different ways of doing it. The best way being using the base Lightning components, where we have record form, record edit form, and record view form, using which we can retrieve the data from the Salesforce org. We can also save the data into the Salesforce org. So that would be the first and the best option. And then we also talked about wire service, which is very much new to the Lightning Web Components there, and how to retrieve the data using the wire service. Then for those who want to directly call the Apex methods, we also talked about the imperative Apex calls, and also talked about how an administrator can configure the page dynamically using the app builder there. with all the design properties that we can give along with the Lightning Web Components. And episode 3 was dedicated to the intercomponent communication, where we started talking about component composition, and we talked about how a component can have another component as its child. So we know that a Lightning Web Component can have a Lightning Web Component as a child. Similarly, Aura Component can also have a Lightning Web Component as a child, but not vice versa. A Lightning Web Component cannot have a Aura Component as a child there. Then we talked about how a parent can communicate with the child using the public API, and how a child can communicate with the parent using the events mechanism. We also talked about how a component not in the same containment hierarchy can talk to another component by using the pub-sub model, right? And we also talked about how a Aura component can interoperate with the Lightning Web component. That's what we have covered so far. Shashank, yeah.
Thank you so much for the great recap, Satya. And for anybody who's wondering where you can find these 3 episodes, in case you haven't attended, we just posted links to episode 1, episode 2, and episode 3, which will have both the recordings and the slides. So over to you, Satya, for the agenda for today.
Yeah. So let me quickly walk through what we are going to learn today. So today we are going to talk about how a Lightning Web Component can share its JavaScript with other Lightning Web Components. And then we'll also see how we can use the static resources within the Lightning Web Component. We'll also talk about how we can use the third-party JavaScript libraries, custom third-party JavaScript libraries in our Lightning Web Components, and how to use that functionality. We'll also cover the most important thing, the trust factor, where we'll talk about Lightning Blocker, which is one of the best security features for Lightning frontend. And then we'll see how we can debug the applications using the browser tools. And then we'll also talk about how to unit test each of our Lightning Web Components.
Yeah, so specifically about working with JavaScript, Satya, in Aura, we have this helper mechanism, and then various ways in which you can share code. And now that we have built LWC with modern JavaScript standards in mind, I'm definitely very curious to understand how we can, work with JavaScript, share JavaScript, use utility style components and stuff like that.
Yes. Okay. When we want to share the JavaScript with some other Lightning Web Component, we can share a single function. As you can see on the screen here, I have a function called myFunction defined in a JavaScript called myfunction.js. In order to share this function, you have to export the function. So whenever a JavaScript has a export statement in it, it is considered to be a ECMAScript module, right? So this ECMAScript module can be imported in another Lightning Web Component by using C/myfunction here in this case. So I'm using C specifically because it belongs to the custom namespace. If you don't define any namespace for your Lightning Web Component, the default namespace is C. So from C/myfunction, I'm importing a function called myfunction. The name doesn't need to be the same name in this case. Why? Because when we are exporting the myfunction there from myfunction.js, we are marking it as default function. So in this case, you can use any of the name. So you can say import my own function from C/myfunction. But if you want to export more than one function or property from your JavaScript, in that case, you can do it by using one of the statements export. Here you can see I have 2 methods. One is get term options, and the other one is calculate monthly payment. So I can export these 2 methods using a single export statement with this curly brace syntax with all these method names separated by commas. And these can be imported with the same names in my component where I want to use this particular code. Okay, this particular code. So you can see that is highlighted, this statement. So we are exporting from the mortgage.js, and we are using the same thing in consumer component.js.
Sounds good. And one more question I have around working with JavaScript is the use of third-party libraries. How can we do that?
Yep. So when you want to work with the third-party libraries, the first thing you need to do is download the library.
Yeah, sounds very obvious.
Yeah. So once you download the library, you have to upload the library as static resource. Again, this is the Lightning Web Component Content Security Policy requirement. So it mandates that if you want to use a third-party library, you should definitely upload the library as a static resource and then start using it as a static resource. Okay, once it is uploaded, we can import the static resource in our JavaScript file and start using it. This is the syntax, how we import the static resource into our JavaScript file. We can import resource name from Salesforce/resource URL and whatever resource name you are given while you are uploading it as a static resource there. And one more important thing we need to do in order to use a third-party library is import a method from platform resource loader module. This is one of the modules which helps us load the JavaScript and CSS files into your JavaScript file. So these are the two methods which we are going to use. One is load script, the other one is load style, which will be importing from the Lightning namespace platform resource loader. And both have very similar syntax, where load script and load style takes two parameters. The first parameter being the current object. Here we'll supply this keyword as a parameter, and the second parameter, which is file URL, is the absolute URL referring to your resource, right? Static resource. And you can notice that this returns something called as promise. You know what is promise, Shashank?
I think, is it the same as what we do to our friends and family?
Obviously, yes. So we promise it, and we don't know when we keep up our promise, right? Yeah. So somewhere later we try to keep up the promise.
Well, there's human error always.
Yeah, but still they'll be waiting for the promise to return. Right, once it returns, probably they are happy. Yes. The same thing happens even in JavaScript.
So is JavaScript more trustworthy when it comes to promises than human beings?
Yeah, than human beings, because it's an asynchronous call. We don't know when it returns, but once it returns with the value. So what we do in a promise is we call this method asynchronously. So for instance, we call the load script method, and then whenever it returns, we can process it. So that will be returned somewhere late in time asynchronously. This is not a synchronous call. But yeah, how to use that? You can use the load script and load style methods in your JavaScript file to load the scripts and CSS, and then once the promise is returned, you can use the callback called then. So within the then block, you can write whatever logic you want to write after the promise is returned.
Can't wait to see a demo of how this looks like, Satya.
Sure. Let's see a quick demo on how to use these things. So the first demo is about how to use the static resources. You can see one of the Lightning Web Component here called miscellaneous static resource, where I'm using two static resources. One is a logo, trailhead logo, and a trailhead character. Let's see the code, how we are using it. If you go back to the code, okay, let me open that file, static resource.js. In order to use the static resource trailhead logo, I'm importing trailhead logo from Salesforce/resource URL/trailhead_logo. And for your information, it is uploaded as static resource. You can go here, open your setup, and you can check the static resources. Let me open the setup for you because we are going to use the static resource even at other places as well.
Yep.
When you are referring the library. Yeah. So here, let me type static resource. You can see that both the resources here, which we are referring, the trailhead logo is already uploaded as static resource here, and also the trailhead characters. These are the things which I am referring in our program there. So here you can see we're getting trailhead logo and we're getting trailhead characters. So once we get that, we can assign it to one of the property of the JavaScript, and then from there you can use in your HTML file. Fine. So this is how we use the static resources. Now let's see how we can share the code from one Lightning component to another Lightning component. For this, I want to choose one example from our miscellaneous example, which is miscellaneous shared JavaScript here. So this calculates the monthly payment for the loan. So it takes principal as input, the term as input, and rate as input. So let us say 5%, and then it calculates how much I need to pay monthly, right? So let's see the code of miscellaneous JavaScript here. So if you see this code, this miscellaneous JavaScript is using one more Lightning Web Component called mortgage, right? Within which we have defined methods like get term options, which returns the terms which you are showing in your pick list here. So you can have 30 years, 20 years, 25 years, these terms. So these things we are getting it from another component called mortgage, and we're also getting a method called calculate monthly payment, which calculates the amount to be paid monthly. Let's open this mortgage and see how it looks. If you see this mortgage.js code, you can see that it has get term options, which is returning all the pick list values which you want to display there. And then this is the method which is calculating all the stuff. And as I talked about this in our presentation, we are exporting these two methods from here. And one more thing, one more important thing, what we can notice here is if you see this mortgage.js folder, right, it has only .js file and meta file. It doesn't have a HTML file. If we remember from our very first web episode 1, like where we talked about two types of Lightning Web Components. One is the user interface based Lightning Web Components and service LWC, service components, right? Service components doesn't show any user interface but provide some service to some other Lightning Web Component which can use that service. So in this case, mortgage is the best example for a service component. And we are getting this component here, and then we can, once we get these two methods, you can use the methods just like that. If you see here, I have calculate monthly payment method, and I'm using the method here. This is how we can share the JavaScript as an ECMAScript module with another Lightning Web Component. So you can see that I'm using import statement, and I'm getting it as an ECMAScript module. Now let's see one more example where we can call the third-party libraries. For that, I would like to choose, let's go to third-party libraries tab, and we have two examples. We have one example, libs D3, which uses the d3.js, a separate JavaScript library for showing the graphs, and then one more component here, which uses the chart.js, again one more JavaScript library to show the charts. So let's select libs D3 file and see how it works. Okay, let me open that file here. So this is the JavaScript file, and I want to use the D3 library, third-party library. So I'll have to upload it in my static resources. You can see in my static resources here, the D3 library is already uploaded, and we can import it as a module here. And then we also need to import two methods as I suggested in the presentation from the platform resource loader module. So load script method loads the scripts into your JavaScript. So it loads the library scripts from the D3, and the other method load style loads the CSS files, if any, if we are using it in our Lightning Web Component program. But how to use that? So here, as we know, load script is a promise and load style is a promise that returns that. But before that, notice that we are calling this method from a lifecycle hook called render callback. If you again recollect from your episode 3, so lifecycle hooks are the hooks which will be called during the execution, during the creation of the Lightning Web Components, or during deletion of the Lightning Web Components. In this case, this method will be called whenever we try to render the page. Whenever we add the component to the DOM, then it is going to call this particular method. So this is the best place where we can, before rendering, we can get all the JavaScript files and start rendering the JavaScript files there. So for that, we are using a load script method, which takes this as the first parameter. And as I said, we have to give the absolute URL. Here we are giving the absolute URL, right? Similarly, for style, we are getting style.css. Again, we are giving an absolute URL here. And notice that these two things are put in a block called promise.all. And what this block does is, it executes all the asynchronous method calls which we put within this block, and it returns once all the methods have returned. Right, in this case, when the script is loaded and also the style sheet is loaded, this promise.all returns. And then, as I said, once the promise returns, we can write our logic. In this case, we are calling one of the methods from the D3 library called initialize D3. Right, and whatever logic, if you are using some other third-party library, you can write your own logic here at this point. And then, if you have an error while loading or for whatsoever reason, that can also be caught using the .catch block here. And in this case, we are catching the error and we are showing it as a toast message in our Lightning Web Component. So these are the three different use cases, Shashank: how to use the static resources, how to share the code between the Lightning Web Components, and also how to use the third-party libraries.
Sounds good. So we're talking about static resources, right? Are there anything we need to be specifically aware of when we are working with static resources?
Yeah, static resources, when I say static resources, it is pretty much same what we have been using so far. Like even while we are working in the Aura programming model, or even while we were working with Visual Force, we have been using the static resources there. So for that matter, you can upload any kind of file like .zip file, jar file, or image files, or even JavaScript files as static resources in your org. And again, as I said, this is the CSP norm. And whenever you are creating a static resource, make sure that the static you follow the static resource naming conventions. The first one is you should not use it can contain underscores and alphanumeric characters, and the names which you are assigning for the static resources should be unique throughout your org, and all the names needs to start with a letter, and it should not include spaces. But if you want to use multiple words, then you can use the underscore there to separate the words. But again, you cannot use 2 consecutive underscores at a time.
Yeah, thank you for answering my question specifically around static resources. Yeah, so I think the next thing to talk about is Locker service. Why do we really need Locker service? What purpose is it serving for our developers?
Okay, Locker service. Let's talk about Locker. It's almost like a watchman for us, which is going to protect our code. So let's try to understand why we need Locker service here. So in order to understand why we need Locker service, let's talk about a few of the notable aspects of JavaScript. We know that JavaScript is a loosely typed language, and everything in the JavaScript is an object, right? And in JavaScript, we can access the DOM fully. And one more important point is browsers also provide access to the events, URLs, cookies. That means more security threat, right? And generally, we persist the state most of the times in the cookies. That's where the hackers or you can drop in and then try to hack our site, or probably include some malicious code. So which generally is called as cross-site scripting. This is one primary risk when we are working with the JavaScript, right? One good solution for that is Locker service. But what Locker service does is it enforces some security features so that your code can overcome any kind of vulnerabilities or security threats. And again, one more important point. So fine, this is all fine. I know that JavaScript has some security issues for which we are using the Locker service. And why, as a Lightning Web Component developer, why would I want to worry about the security, right? What happens when we develop the Lightning Web Components? Let's see the scenario here. So I have a Lightning app which is running in the browser, which may have different components, maybe provided by the which comes out of the box, provided by the Salesforce. It may have the components which are provided by some third-party vendors as well. Like here, you can see component 4, 5, and one more component from the vendor 3, right? So these components can, in fact, because they have access to the DOM as basic nature of JavaScript, right? We can access the DOM of each other component. So from that, from the DOM, let us say the component 4 of vendor 1 can access one of the elements of component 3 from vendor Salesforce. So this is quite possible. Not only that, any other component can access the elements of the other component, which leads to a security threat. That's where the locker service is going to help us, right? Help us as a Lightning Web Components developer. When we develop the components, we really need not worry about the security factor, because the Lightning Web Components programming model comes with the locker service enabled by default. So let's see the what locker service does exactly, right? As I said, it provides some of the security features. The first thing is JavaScript strict mode enforcement. So normally, if you want to enforce the strict mode in your JavaScript, we use the keyword like use strict, right? But when we use the locker service, it comes by default. So what does the strict mode mean? So when we say strict mode, if you want to use any of the variables in your JavaScript, you'll have to define it or declare it before using it, using any of the keywords like var, let, or constant. And then if you want to share the code between different components, then you'll have to export it as a module from one component and then import it as a module in another component. Then only you'll be able to use the JavaScript in other modules. And one more important thing is, if you are using any of the third-party libraries, those libraries should also work in strict mode. The second important feature, security feature provided by locker service is DOM access containment, where you cannot access the window object or document object directly. That means you are protecting the elements of some other Lightning Web component to this component, or you are protecting your components so that no one else is going to access your component. And if at all you want to use any of these things, then it provides a wrapper around it, a security wrapper, so that it provides access only to your particular component. And one more important security feature it provides is it restricts access to the Salesforce global variables, which are otherwise available for most of the Salesforce features, like in this case $A, Aura, SFDC, and Salesforce. It restricts access to these global variables for primarily two reasons. One reason is some of these global variables are deprecated. The other reason is if we use these global variables, it is going to interfere with the working of the other components. So that's why we are protecting the components. And
yeah, so one more thing is unsupported browsers, things like Internet Explorer and stuff. How does Lightning Locker work there?
That's exactly what I was trying to talk about, right? So yeah, so what happens if there is a browser which doesn't support the locker service? Will our code work? Will not work? It will definitely work, but in that case, locker service is disabled by default. Right, so it's always suggested that you use the web browsers which support the locker service. And then the last but not the least point, most important point, in fact, is content security policy, which is a W3C standard, which provides some security features which we need to follow as restrictions. In this case, if you want to use any of the JavaScript libraries, you'll have to always upload the library as a Salesforce static resources. Right? And if you are using any of the external fonts or any of the resources like CSS, in that case, you'll have to refer to those resources only using the secure HTTP link, HTTPS. You cannot access it using the HTTP. And script tags can't be used to load the JavaScript, basically. And one more important point is when you are using the HTML, and if in that case, you cannot write inline JavaScript for the handlers of any of the events, like when you click on click or on change kind of events, you cannot write inline JavaScript. You cannot call the JavaScript functions from within the HTML element. That is one more important enforcement done by the CSP. And if you do any violations, how do you get to know that you are doing the CSP violations? When you run the code in your browser, you can see that it in fact provides the warnings in your console that you are violating the CSP policies.
And all this brings me to the question of debugging, right? So it's JavaScript runs in the browser, violations are shown in the browser. But generally for debugging as a developer, how should we go about it in Lightning Web Components?
Yeah, that's one very important point, debugging. When we write the code, first thing is like we should take utmost care so not make any mistakes. That's what generally programmers try to do. So to do that, let's see what are the benefits we get from one of our favorite IDE Visual Studio Code, in which we have installed the Lightning Web Components extension, right, as a part of Salesforce extensions package. So when we install that Lightning Web Components extension, we can use that component to identify the JavaScript errors whenever there is a declared property which is not being used, or any kind of JavaScript errors. It shows it in red mark, because when we install this LWC extension, it by default installs ESLint as well. So ESLint will take care of identifying any errors in your JavaScript, and it throws the error. So that's how the developer can easily fix it. Not only that, when you are working on the HTML part, when you are working on the markup as well, if you type a tag and you want some help about it, so it provides the intelligence, right? And if there are any errors in the HTML as well are reported then and there itself in your IDE, and so you can easily fix it. But yeah, so even a very good programmer generally makes some mistakes which are only identifiable during your execution of the program, right? When you port it and start using it. So in that case, how do you debug the code? So we have some tools available in the market, like Chrome developer tools or Firebug from Firefox. We can use these tools in order to debug your code, right? So you can debug your code while it is running in the production mode, or you can specifically debug the code. If you're developing the application, you can enable the debug mode and also debug your code in the debug mode. So what are the fundamental differences? When we try to debug using the production mode, we know that when we render the JavaScript is rendered as a minified file. Minified means what it does is it renames the properties, and sometimes it removes the warnings, which are not very important. So that way it improves the performance of the execution of your JavaScript. So you have a minified JavaScript code, so you have limited probability of identifying the issue when you're using the production mode. And not only that, if you're using any of the decorators like @wire, @track, and other stuff, in that case, those values are displayed as proxy values when you're using the production mode. We'll see how it looks with a short demo. Right, but if you're using the debug mode, then you are working unminified JavaScript code, means you have access to the complete code there, so that you can easily debug it. And not only that, all your data is showed as the regular data, even if it is decorated with track or wire there, right? And if there are any specific Lightning Web Components engine warnings, then you can also see those warnings in the debug mode, so that you can fix those things and improve your Lightning Web Component there.
I can't wait to see a demo of this, Satya.
Yes, let's see a demo of debugging. So for this, I'll choose any one of the components. Let me choose from parent to child. We have a component called API Setter Getter, which has a button, which has a checkbox. So when I click this checkbox, it shows the priority only, right? So it shows the to-do items which are on priority. Now let's see how we can have this, we can debug this particular code. In order to do that, you can go to the developer tools. You can go to developer tools from here, from more tools, and select the developer tools. Or alternatively, you can use any of your shortcut keys. If you are using macOS, you can use Command Option I, and if you are using Windows, you can use Control Shift I, which automatically launches the developer tools for you. In this, you can go to the sources, and in sources you can find something called modules. Within the module, you can find your whatever component you're trying to look. In my case, I want to see the to-do list. Let me go to to-do list here. Here I have to-do list, and you can see that it shows the minified version, right? And it's not really easy to read because it's a very, very long line.
It's just one line of code, which actually multiple, like 100 lines of code or something like that.
Right, it's having more than 1,000 characters there.
Yeah.
So we can see a better version of it by clicking this pretty print there. When you click pretty print, you can see this version is little better, right?
Like how a developer would write it, right?
Exactly. And this is the production org, where I'm just putting a breakpoint here, and let us refresh the page. it refreshes, it runs the code, it stops at the breakpoint. Right, so you can see that it stopped at the breakpoint. Then I can easily monitor the values, track the values. In this case, my priority filter is set to false, and then I have this .to_todos, which is displayed as a proxy. You can see because it is in the production mode, it is displayed as a proxy. But how do you run it in the debug mode? For that, I've opened one more arc here where I opened my application, the same application, parent to child, where I want to debug the things. But how do you set the debug mode? You need to go to setup. You can go to setup there and you can type debug mode, and you can see that there are a list of users for whom you want to enable the debug mode. Again, be careful for which users you want to enable, because this is going to reduce the performance of your application. In this case, I've enabled it for user, right? And then I'm running this code in debug mode, and you can also see a beautiful warning here at the top, which generally pops up every week if you don't disable the debug mode. It warns you that it's going to affect your performance there. Fine, I opened the same to-do list code, and you can see the difference here. So you can see the filter tools to-dos method here, and the same filter to-dos method is in a different displayed in a different way. So let me put a breakpoint here as well, and let us try to refresh this page. See, when we refresh this page, let's see the values of the priority here, right? And also the priority filter. You can see the priority filter value is false, and you can also see this _todos. Now you can see it shows the real data. It doesn't show proxy anymore, right? Whereas in this case, this was showing a proxy. This is showing a proxy. So this is the difference. This is how we can debug the code in by using the debug mode in a better way. Not only that, I want to show one more important point here. Let us continue the execution. Let us go to this debug version. If you go to the console, you can see the warnings being displayed here. The same will not be done when you go to the console here. You don't see any warnings in the production mode. As I said, right, Lightning Web Components warnings will be displayed in your console when you're using the debug mode. And you can see I'm seeing different kinds of messages here, info, warning, errors, and other stuff. And I can directly get to the code by clicking any of the links here and fix the things. And if you want to see a better set of warnings, readable warnings there, so I'm removing all the errors. I'm saying hide all. You can see these are the different warnings that are thrown by our Lightning Web Components engine. Right, so this is how we can debug application and easily identify the errors. We can trace through. We can go to the next step by using the small icons on the right side in your developer tools, and you can step through each of the lines of your code and see where your code is not behaving properly.
Yeah, it makes sense to use browser tools for something that runs on the browser, right?
Yep.
Yeah. So this is for when you have bugs or issues or when you're troubleshooting something. But what about testing, right? Testing is, in my opinion, it's the most important thing when you're building something as a developer, because you want to know if your code is doing what it's supposed to do. So can you please help us with understanding testing Lightning Web Components?
Definitely. So unit testing is not so new. At the same time, I can say it's little new when we talk about unit testing Lightning Web Components part. The difference is, like earlier we used to do it in our browser itself in the web. Now we are going to do it on our local system. Let's try to understand. First, let's see what is unit testing. It's a software testing method to test a standalone module to determine whether it is meeting the expected behavior. This is the most common definition where we are trying to identify, check whether our Lightning Web Component is meeting the expected behavior. Then why do we need to do the unit testing? The first most important reason is with unit testing, you can identify the bugs much early. So if you deploy the code and see the bug later, it's going to impose some cost on you. Right? But with unit testing, you can identify the bugs much earlier. Then how to do the unit testing? Lightning Web Components context. You can see that you can write the code can write the test, then you can run the test. When you run the test, your test can pass, in which case you can deploy the code, or it can fail, in which case you refactor the code, again run the code and deploy the code. But again, when we deploy the code, if you get a new change requirement, you need to write a test for that, and you also need to write a code.
Yeah. So what do we use? What is actually the tool that we use for basically testing? Because if you talk about Apex, we have the Apex unit testing framework that is available right inside the platform on the browser. So what is the equivalent of that for Lightning components? Do we just use the same framework, or is there a new tool? How is it going to be like?
Yeah, that's an interesting question, Shashank. If we see here, Jest is one of the frameworks which we are going to use for our unit testing purpose. I picked the definition of Jest from Wikipedia, and you can see that it's a testing framework with a focus on simplicity. So that's the reason I love Jest, where we can write the unit test very easily, and we can also test it. Normally, when we do testing, there are two ways of testing. One is manual testing, and the other one is automation testing. In most of the cases, when we write the unit tests, these unit tests are done with automation. Right? Jest framework is one of the best frameworks which we can use to do the automation testing. Now, in order to use the Jest, what are the different things that we need to do as a Lightning Web Component developer? Now, I'm talking Salesforce developer's perspective. This is little new there, wherein we'll have to install few prerequisites.
And these prerequisites are the usual suspects, which are Node.js and NPM, which is basically needed for any of the Node.js based frameworks, right? And it looks like Jest is the Node.js based framework.
Yes, it's the Node.js based framework. That's the reason we need to install Node.js, and Node.js also comes with a Node.js package manager, which is called as NPM. Right. So how do we do the installation? Installation is pretty simple. What you need to do is you need to run 3 commands there. One is npm, the other one is npm install, and the third one is npm install at Salesforce LWC Jest. Now, what does these 3 commands do? So we run these commands at the top level directory of your project. We do it for each project so that we load dependencies only for the project, and then we use those dependencies from the project. Now, when you run the npm command, it creates a package.json file which holds the information about your project. And when you run the npm install command, it creates a package log.json file which can hold the information about your Jest installation, which can hold the information about your Jest installation, and also all the dependencies. Right? So these 2 commands, in fact, just creates 2 files for you. But third command is a very important command, where we install at Salesforce /LWC Jest. In this case, we install the Jest framework and also all the dependencies that are required to run the Jest framework, right? And your package log.json is automatically updated with all the dependencies. And these dependencies are loaded into your folder, project folder. That's all we need to do for the installation part. But in order to write a test, we need to do a little bit of configuration. That's again for the best practice. Some things for the best practice, some things may be mandatory. But yeah, let's try to understand what are the configurations that we need to do there. The first one is in package.json, whichever commands you want to run using Jest framework, you can list those commands. Probably you may want to run the unit test simply, or you may want to watch the variables while running the unit test, or you may want to debug the code. So you have different commands for those, and you can add those commands, which we will see in our demo there. And then we create a folder called __test _ in each of the Lightning Web Components folders. So all our tests can be written within this folder. The primary purpose why we are creating this folder is we don't want to check in this code into Salesforce Arc, right? So we want to run the unit tests locally on our system. So we can do that by writing it in a separate folder and then including that folder in your .force ignore file. When we include it in .force ignore file, whenever you deploy, this folder is not deployed into your org there.
Because you don't have to install the test classes inside the org, right?
Exactly.
Unlike in Apex where you have to run the tests. So we're not doing it for code coverage, but we are doing it for good code, is what I understand.
Exactly.
Okay.
So there's a development technique called test-driven development, where people tend to write the unit tests even before writing the code.
Yeah.
Right.
Yep. Okay. Can you give us like a sample of how a just test looks like?
Sure. So let's see how a just test file looks like. So I have a very simple use case here where we are testing the hello world component. So you can see the first two statements which are important, where we are importing create element from LWC. And this create element method is not available for your Lightning Web components. It's only available in the test context. It's only available for the test files. So we can create elements from the test files. I'll tell the reason a little later in our demo here. But yeah, we need to import create element from LWC, and whichever component you want to test, you also import that. That's it. Once you import those things, you can define a test suite using the keyword called describe. So this describe block contains one or more tests. You can write any number of tests within the describe block. You can group the tests together and write in the describe blocks, right? So what I suggest is you always create at least one top level describe block, right? And then if you have more complex tests, then you can write more describe blocks there. But you can have one, in this case, we have one describe block with one very simple test case. Now, if you see at the bottom, we have a test case wherein it's it block. In fact, you can also write TEST there. It is a small form of test. You can use any of these aliases. You can use either test or it there. And your complete test code goes into this block, right? And how does that work? The first thing we do is, because we are running it on our local system, we are not running it on the browser, we don't have access to the DOM, for which Node.js provides a module called JS DOM, right? So what you can do is you can create the element for your component and add it to the local DOM, JS DOM, and then access it as if you are accessing it from your browser there. So in this case, what we are doing is we are creating an element for the hello component. So you can notice that I'm taking the hello from that import there. So whatever I got as a module, ECMA module, and then I'm creating an element called c-hello here. Once we create that element, we can append it to the JS DOM by calling the method document.body.append child, right, which is going to add your element to the local JS DOM there, right? And then we have a we can query the elements from the local JS DOM using element.shadowroot, and we can call the query selector method. So if you want to compare it with your Lightning Web components, this is what we do using this dot template, which refers to your shadow root of your virtual DOM there, right? So that's what we are doing here, and we are getting the div. Once we have that div, this is the statement where we are testing for success, where we are testing for the assertion. So if you see that here, we are asserting that whatever text content that is there in your div should be hello world, right? And note in this statement, so this is an expect statement which has something called .2b, which is called as matcher. So there are a list of matches which are well documented in the just documentation, and you can use the matches like to be, not to be, falsy, truthy. There are a lot of matches, greater than, less than, and depending upon your test requirement, you can use any of these matches there.
Okay, great. Yeah, so if I look at the last statement, expect to be similar to the system assert that we have in the Apex classes, right? That's pretty much the mechanism of testing is similar, and the framework is different. That's the only thing, I guess.
Okay, let me let me show a quick demo of this testing. So if you see here, so I have the same code here, whatever I have described in my presentation there. I have the same set of statements. So I'm testing for a statement called hello comma world. This great thing is populated with world here. So how do you run that test? We can you can see that in your test.js file, say let's see the package.json, and let's see one of the commands there. If you see the package.json, so we have a command to test here, which I written as test:unit, which runs the LWC test. So let's run this test on this component here. So if I say npm, I'll be using npm run method to run my test here. So I can say test:unit, and then let us run this test. So what it does is it runs the test, and it checks for the assertion, and once the assertion is there, it gives either in green, which is good if it gives in green, but if it gives in red, then the test is failed. In this case, you can see that it has given it in green, right? And yeah, and if you do anything wrong there, then it's going to show it in red color, and you can fix it.
Sounds good. That's a great demo, Satya. Thank you so much for the quick running of the test. The demo gods has also been kind with us, I guess. Our demo also ran very quickly. It looks like the Jest is a very fast testing framework.
Exactly, and it's very simple as well.
Sounds great. Okay, that's kind of pretty much brings us to the end of our content that we have for today. Let me just give you a quick overview of what we're going to do in episode 5. This is a finale of the series that we have been doing on Lightning Web Components. We're going to do live coding for the first time with Lightning Web Components, where we basically practice what we learned over the last 4 episodes, including this one. And then we implement a business scenario and see what is the developer experience like while building Lightning Web Components. We'll write the code live, we'll test it live, we'll debug it live. Hopefully we make some errors like any other developer does, and we have to debug it and then see what we have done wrong. And we'll also share some best practices around what are the various things that you can use to basically build Lightning Web Components. It's going to be a very interactive webinar, and it's the last episode. Even if you haven't watched the 4 episodes, you can definitely join. And we're going to post a link to register for the episode. We have already posted it inside the chat window. Please feel free to register for the live webinar. It's going to be a very interesting one. We are also very excited about that one.
That's definitely a good idea, Shashank, where we have talked about a lot of things in our 4 episodes there, and then we are going to use all those concepts to build a use case, right?
Yeah. Whether you watched the previous episodes or not, by now you already have all the links. If you haven't, you still don't have to worry. You can still watch them and come back to episode 5. And you can come to episode 5 even without watching the episode, because it's going to build something live, and you can learn from looking at how we are actually building it. And who knows, maybe you can even try it out yourself parallelly on your machine as well. Maybe use like dual screens, or do it along with us, build something along with us. Let's make that happen. Are you excited, Satya, for that?
Yeah, I'm most excited, and I'm waiting for that.
Okay, with that, before we go into the Q&A, we want to just share a couple of resources that we share in our webinars to learn more about Lightning Web Components. We have a couple of Trailhead modules. One is the Modern JavaScript Development module, which has nothing to do with Lightning Web Components, but it is basically about modern JavaScript that Lightning Web Components uses, and it's important to understand things like promises is one concept that we spoke about. ES6 modules and all these things are going to be covered in the modern JavaScript development.
And I was also talking about CSP stuff, like how do you declare the variables and all, everything's covered.
Exactly, everything's covered there. And once you're done with that, we have a specific trail mix for Lightning Web Components content, Lightning Web Components batches and modules and projects. So the link for it is right there, salesforce.co/LWC. Pretty easy to remember link, and you can get all the Trailhead content related to Lightning Web Components in one single list. So with that, let's go into Q&A. Please feel free to join our webinar group, bit.ly/webinar APAC, to stay in touch. We just posted a link as well inside the chat. And now let's look at some questions. Satya, are you ready?
Yeah.
Okay, let's see. I see that there are some pretty good, interesting questions that have come. Let's try to address as many as possible, right?
Right.
So one question is, to reuse a service LWC, is there a requirement where they should be placed in the folder? And that is one part of the question. And the other part is, to use a component as a service component, can we use any JS in components which have an HTML file?
Yeah. So the question is all about how do we reuse the LWC components? Can we do it? So do we need to put it in the same folder? So I'll answer again it in two parts. The first thing is you can export it as a ECMAScript module, and then you can use it in your code. Or if you have the JS file, you can also put it in one of the folders locally, and then you can export it as ./ that folder / dot. And you can access those.
Yeah, basically it has to be just in the LWC folder, right?
Exactly.
That's pretty much what is needed. And once it's there, it can be imported as a module into any component.
Any component.
No matter whether it has an HTML file or not, whether it's inside a component bundle or not. That's the beauty of modern JavaScript, I guess.
And if you don't have an HTML file, that's where we call it as service components, right? That's not mandatory.
Yeah, so there are questions around developer console and Eclipse and stuff. One thing to highlight is, I mean, again, we have already covered in the first episode, but just to reiterate, you need Visual Studio Code with Lightning Web Components extension to build Lightning Web Components. You won't be able to do it on the developer console. You won't be able to do it on Eclipse. Maybe on Eclipse, but the suggested one is Visual Studio Code with the Lightning Web Components extension.
Yeah, that's where we get more benefit from this extension, right? Like,
okay.
Yeah.
Yep. So there is one question around rendered callback. So will it be called before rendering the DOM or after the rendering of the DOM?
It will be called before rendering the DOM.
Cool. Okay. So can we use just for Aura testing as well?
So just as a framework can be used to test any kind of JavaScript, right? So you can test Aura, you can test React, you can test our Lightning Web Components as well.
Yeah, that's pretty much it. So there's a question around the catch block inside the promise. So can catch exist without the try? Like an example, the answer is yes, because this is a way of handling promises, right? So in promises, you just have to say then instead of try. Right. That's all it has.
And you can also use finally as well.
You can say finally as well. Yeah. What if the promise did not return on time as it's asynchronous, so it affects performance? So the whole idea of making it asynchronous is to improve performance. When something is asynchronous, you don't have to return for the result of that.
Right.
So it actually takes care of performance.
Yeah.
The page will definitely load. The result will be.
It's the other way around.
It's other way around. Yeah. Is there a concept of extensions in LWC? No, we don't have controller extensions in LWC, but there is a lot more flexibility with the way JavaScript code can be shared between various components.
Right. In fact, you can also use the controllers. You can call the controllers from your Lightning Web component program, basically.
Exactly. Yeah, so does locker service work by default or do you have to enable it manually? The answer simply is it is enabled by default. You don't have to worry about it.
Yeah.
So there is some API version that you need
exactly.
to get.
I believe we are currently in version 45, and right from version 40, this is enabled by default.
And if you don't want to use locker service, you have to change the API version on the component to less than 40.
Exactly. That's for our programming model. We'll not do it for Lightning Web Components anyway.
Yeah, okay, let's see. Let's take some more questions. Is there a requirement for code coverage for LWC JavaScript for deployment? Like we spoke about, you don't really need code coverage like Apex does.
Yeah.
You can deploy Lightning Web Components without the test classes, right?
Exactly. And see, we are using these unit tests to identify the problems well before it is deployed. Okay, that's for the benefit of the developer. And yeah, but still, if you want to check the code coverage, you can still do it using the Jest framework, but it's not mandatory.
Yeah, quite a few questions around test classes. Are they similar to Apex test classes? Idea-wise, they're same. They are testing the code, but implementation-wise, it is not part of the platform. Just is outside the platform. It's a open sourced public framework that we use for any kind of JavaScript.
Right. And one more thing is we are doing it in Apex, and here we are doing it in JavaScript.
Exactly, completely different programming languages, completely different technological stack as well.
Yeah, but the concept is almost same, where we are setting for some value to be true.
Yep. And can we use Mocha for unit testing LWC? You can definitely do that.
Yes.
Right. You can use any, but Jest has additional simplicity that comes with it, and it is our recommended framework for testing. And we also built like an extension for LWC, specifically for Jest. So any LWC specific quirks, Jest will be able to test them.
Right. For that matter, you can use Mocha or Jasmine, whatever you want. But yeah, Jest is the best framework, which I love it.
Okay, so can we get this code via GitHub for this session? The good news is whatever demos we have been showing in all the episodes are already available on GitHub through the sample gallery, right? So we're going to post a link to the sample gallery where you can actually get the code for the recipes application that we have been using for this specific webinar series as well.
Right. And one more important point to be noted here is like when we are using the recipes app there, each of the recipes in the recipes app is provided with a test case, right? A test folder. You can see that there are no recipes that are left out without a test folder there. So you can see a lot of variations of how to write the test for each of the use cases. So that is the best thing, which I suggest for the viewers of the webinar to go back and see the test folders for any kind of use case you want to learn about.
Yep, the best way to learn is the recipes application, which has basically code samples for most of the use cases that you would need to Lightning Web Components, and all the components have tests written for it.
Exactly.
Each component, we already written tests for all of them, so you can just look at that and learn from them. Okay, I think we got some great questions. Thank you so much, everybody, for the questions. Thank you so much for attending. And you'll also receive an email to provide us feedback on how you think the webinar has gone. It helps us, improve the webinar, get you the content that you're looking for and stuff. And with that, thank you so much for attending, and see you in a couple of weeks on the next Friday in our live coding webinar.
Thank you all.
Thank you so much.